So here's the reason I went the long way of finding tax and finding a sales, or a percent increase and a percent decrease. It's for this one formula we need to come up with. So the percent change formulas, new minus old over old, times 100 is equal to x as a percent. Alright, so far what we've solved for is we've solved for the new and we solved for the percent. But there is one other thing that we can solve for, and that's old. And the problem with old is it lands in two locations, one on the top and one on the bottom. So it makes it a little bit more difficult to use this formula to solve for. So what we're going to do is we're going to adjust this formula so we can find the old really quickly. And the only way to adjust a formula without losing track of where all the pieces are going is to replace all the variables with variables and just leave it alone. So before I replace new with n, so that's perfectly fine. Old would be perfect if it, I could put an O here and understand it, but that would look like a 0, so I'm going to use G for grandma, because I'll think of that as old. So that would also be divided by G times 100, oops, what happened there? Times 100, and this will equal our x percent. So I'll just leave him as x. Alright, so what I want to solve for in this case is G. So solve for G. One nice thing about solving equations with just a bunch of letters is there's zero calculations to handle. It's just pure algebra. So we're going to go through the same steps that we did before with the sale and the tax problem. So if I go back to the sale problem, the first step that I had was divide both sides by 100. Alright, we can do that. So come back here, divide both sides by 100. And again, remember that dividing by 100 has no effect on this over here, because this whole green thing on the left hand side is one term. Alright, so the hundreds over here are going to cancel. You're left with n minus grandma over grandma, new minus old over old, is equal to x over 100. And there's nothing I can do with that, so I'm just going to leave it as x over 100. Alright, the next step, if I go back, after step number 1, dividing by 100, step number 2 was getting rid of this number in the bottom here. So multiplying both sides by that common denominator. So back to this page. If we're worried about the bottom, then the bottom here is this G. So I'm going to multiply both sides by G. Okay. So over here they're going to cancel, and you're left with the numerator, which is n minus G. And that's now going to equal x over 100 times G. And there's nothing we can do with that because it's, two letters and one number. Alright, I'm going to have to move it up over here. And I'll write it down again. N minus G. Actually, I'm going to cheat. Instead of writing it all over again. Ew, that's not what I wanted. Maybe I can't cheat. Ah. There we go. Alright, so if we start here, the next step would be back to this one over here. Third step was add that number over to the other side, the number that's left over. In this case, G was 150. So here we're just going to add G to both sides. Now adding G to the right hand side is not going to be as easy as adding two numbers. So let me look at the right hand side a little bit different. So let me add on a new page here. A little algebra skill. So if you have 2x plus 3x, we know that's equal to 5x. The problem comes if I say ax plus bx. These are still like terms, just like 2x and 3x, so you should be able to combine like terms. So the trick is this. When you recognize like terms, you basically ignore the variable and you concentrate on just the numbers. So you look at this problem like 2 plus 3 in your mind, and you add those two numbers together to come up with the 5 over here. And then you just bring the like term back into play. That's actually the distributive property, which basically says two things. You can distribute in or you can distribute out. So what I want to distribute out here is the x. So if you kick out the x, what's left behind is a, the plus, and the b. So this becomes a plus b times x. Now the same thing happens up here. We could kick out the x. Left behind then would be 2 plus 3, which of course equals 5, and then you get the x next to it. So if I use that kind of trick, what we're going to have over here when I write this down is that n is equal to g plus x over 100 g. And these are like terms because they both have this g. So by that kicking out, also known as factoring, process, we can kick out a g. And what's left behind is the coefficients. Now the coefficient of g by itself is 1. So that goes here. The coefficient of this g is whatever is to the left of it. It's this weird thing, x over 100. And we get this new formula that you can also use to find what n is equal to, but it's the only one that allows you to find what g is equal to. So this formula is really used to solve for the old value, grandma. But you could use it also to find the new value if you wish. Alright, so let's use this thing. This one. Ooh, let's go back here for a second. I want to steal that. Nope, too much. There we go. Copy. Use that formula here. Nope, lost a little bit of the n, but that's okay. Alright, so we get n equals parentheses 1 plus x over 100 times g. Now be careful here. X is either a positive value or x could be a negative value. That all depends on if it's a percent increase or a percent decrease. So it's positive if it's a percent increase, a tax, an increase in value, a markup price. It's negative if it's a percent decrease, or a sale, or a marked down value. Alright, so here we have the sales price of a coat is $90.50 after a price reduction of 40%. What was the original cost of the coat? So this is how much the sale price was. Maybe you're interested in what was its original value, which was its original cost. So when we go and use this formula, when I say new, we used to not know it, but in this case, this is the new value because this is the final cost of the coat. So that's going to go in this spot, 90.50 is equal to, we're going to write 1. Don't write the plus too fast because it's either going to be plus if it's an increase or minus if it's a decrease. So this is a price reduction, so that means it's going to be a percent decrease. So this 40% is really negative, and it'll be 40 is the x, and that 100 has to stay under it. And then g, we don't know the original old value. Remember, g is grandma. So how do I solve for g? Well, I got to take this number in front of it and figure out what it is. So 1 minus 40 divided by 100, it should be 0.6. So this would be 90.50 is equal to 0.6, and if you want 0.60, that's perfectly fine, g. Now to solve for g from here is actually kind of easy. You just divide both sides by 0.60. So 90/50 divided by 0.6. So 150, so g, change colors, is going to equal 150 point, and on the calculator it's 833333333, but remember this is money, so this will be 83 cents. We want to round to the nearest hundredth or second decimal value. And we also want to make sure it's money because we're talking about how much it costs to begin with. And that's it. That's how you would use the percent change formula, a different one, to find a percent decrease. Alright, here's one that goes to the worksheet that I handed out. And this is just a very small part of it. So in July 2014, there's 58 million people that were looking for jobs. This was a negative 0.4 change from the previous month. How many people were looking for jobs in June 2013? That should be 2014. Previous month, 2014. All right, so you started in July. Previous month was June. Now this, you have to be careful. This is literally a percent change. So it jumps right into the percent change formula. This 58 million people, is it the new one or is it the old one? Well, this is a change from June to July, so this becomes the new value. Compared to the old value is a negative 0.4% change compared to June. Alright, so this is definitely a new minus old type problem. The problem is you're looking for old, which in our new formula is grandma. So we have to use the new value equals 1 plus x over 100 times grandma, the old value, and plug in what we know. So the new value is 58 million people. I'm just going to write 58 and understand that our answers are going to be in the millions. This is going to be 1. This tells you exactly what sign you should be because this is a negative 0.04. So you write negative 0.4 divided by 100. Don't be trying to change this into a decimal, just let the calculator do its work. And then times g. Alright, so 1 minus 0.4 divided by 100 is 0.996. So this becomes 58 is equal to 0.996 times the old value. And then to solve that, you divide both sides by 0.996. And finding the old value now becomes really easy. And we get a final answer of, well, let's see here, 58 divided by 0.996. 58.2. So G in this case would be 58.2. And since it's not really 58.2, it's in the millions. So this would be 58.2 million people were looking for jobs in 2014.